Consider a scenario where you must store the address of an employee in a table and you may have to refer to each field of the address occasionally. In such a case, storing the complete address as a single record comprising the street name, door number, and so on would be an effective solution. There are instances where an employee may have more than one contact number. At times, the employee may have only one. The number of contact numbers is not definite, yet you still want to have all the contact numbers in the database. Storing all the contact numbers as a collection would be an effective solution for this situation. Use place SQL records when you want to store values of different data types that are logically related. For example, you can create a place SQL record to hold employee details and indicate that all the values stored are related because they provide information about a particular employee. Use place SQL collections when you want to store values of the same data type. Note that this data type can also be of the composite type, such as records. You can define a collection to hold the emails of all employees. You may have stored n emails in the collection, however, email 1 is not related to email 2. The relation between these emails is only that they are employee emails. These collections are similar to arrays in programming languages such as C, C++, and Java. It is appraisal time and the HR manager has the job of updating all the organizational changes in the system. To reflect a promotion in the organization, the following operations are to be carried out in the database. 1. Update the job_id in the employees table according to the promotion. 2. Add the old job details to the job_history table in relation to the employee. 3. Update the salary field in the employees table according to the new job. When you implement this task in place SQL, it would be a better option to retrieve all the details of the employee into the place SQL block, update or manipulate them, and then write the details back into the database. Place SQL records are user-defined composite types. You must create the record type first, and then declare an identifier by using that type. To use them, perform the following steps. 1. Define the record in the declarative section of a place SQL block. The syntax for defining the record is shown in the slide. 2. Declare, and optionally initialize, the internal components of this record type. In the example in the slide, a place SQL record is created by using the required two-step process. 1. A record type, T_rec, is defined. 2. A record, V_myrec, of the T_rec type is declared. You retrieve values from the employees table through a select statement into the record, and then access the fields of the record. You access the fields in a record with the name of the record. To reference or initialize an individual field, use the dot notation, record_name, field_name. For example, you reference the job_id field in the emp_record as follows, emp_record.job_id. You can then assign a value to the record field, emp_record.job_id equals street_clerk. In a block or subprogram, user-defined records are instantiated when you enter the block or subprogram. They cease to exist when you exit the block or subprogram. When you declare a record, you may want to have the record fields to be exactly same as the definition of some table in the database. You can use %rowType attribute in this scenario. The %rowType attribute is to a record what the %type attribute is to a variable type. The %rowType attribute is used to declare a record that can hold an entire row of a table or view. The fields in the record take their names and data types from the columns of the table or view. The record can also store an entire row of data fetched from a cursor or cursor variable. The example in the slide shows the usage of the ROWTYPE declaration. The code in the slide has a new field added, V_rec1, which is a row from the employees table. The V_rec1 field in the record declaration is a row from the employees table. The V_myrec variable is a record variable of type T_rec. The advantages of using the %rowType attribute are listed in the slide. Use the %rowType attribute when you are not sure about the structure of the underlying database table. Using %rowType simplifies maintenance, which is its main advantage. Using %rowType ensures that the data types of the variables declared with this attribute change dynamically when the underlying table is altered. If a DDL statement changes the columns in a table, the place SQL program unit is invalidated. When the program is recompiled, it automatically reflects the new table format. Another example of the %rowType attribute is shown in the slide. If an employee is retiring, information about that employee is added to a table that holds information about retired employees. The user supplies the employee number. The record of the employee specified by the user is retrieved from the employees table and stored in the emp_rec variable, which is declared by using the %row type attribute. Compare the insert statement in the previous slide with the insert statement in this slide. The emp_rec record is of type retired_emps. The number of fields in the record must be equal to the number of field names in the into clause. You can use this record to insert values into a table. This makes the code more readable. Examine the select statement in the slide. You select hire_date twice and insert the hire_date value in the leave date field of retired_emps. Practically no employee retires on the hire date. The inserted record is shown in the slide. You will see how to update this in the next slide. You learn to insert a row by using a record. This slide shows you how to update a row by using a record. The row keyword is used to represent the entire row. The code shown in the slide updates the leave date field of the employee. The record is updated as shown in the slide. An associative array is a type of place SQL collection. It is a single-dimensional array where each element in the collection is referred to through an index value. You can store data in an associative array by using a primary key value as the index, where the key values are not necessarily sequential. Associative arrays are sets of key value pairs. Each key is a unique index, which is used to locate the associated value with the syntax variable _name, index. Associative arrays have two columns, a key column and a value column. The first column is a key column, which is used to index the value column. The key column helps you to uniquely access a certain value column. The second column holds a value. Unique key column. The data type of the key column can be numeric, either binary_integer or PLS_integer. These two numeric data types require less storage than number, and arithmetic operations on these data types are faster than the number. Arithmetic. Varchar2 or one of its subtypes. Two steps are involved in creating an associative array. 1. Declare a table data type by using the index by option. 2. Declare a variable of that data type. Type_name is the name of the table type. This name is used in the subsequent declaration of the array identifier. Column_type is any scalar or composite data type such as varchar2, date, number, or %type. You can use the %type attribute to provide the column data type. Identifier is the name of the identifier that represents an entire associative array. The example in the slide creates an associative array with the identifier, email_list. In the executable section, the associative array is initialized with 3 elements at indexes 100, 105, and 110. The index of each associative array element is used to access an element in the array, by using the following syntax. Identifier, index, in the dbms_output. Put_line statement. You access the elements of the associative array and display them as output. As previously discussed, an associative array that is declared as a table of scalar data type can store the details of only one column in a database table. However, there is often a need to store all the columns retrieved by a query. Associative arrays enable you to hold rows of data from a table in the value column. A collection method is a built-in procedure or function that operates on an associative array, and is called by using the dot notation as shown in the slide. The example in the slide declares an associative array to temporarily store the details of employees whose employee IDs are between 100 and 104. The variable name for the array is emp_table_type. Using a loop, the information of the employees is retrieved from the employees table and stored in the array. Another loop is used to print the last names from the array. Note the use of the first and last methods in the example. Consider a situation where the HR manager has to store all the email IDs of employees working in a department. In this case, using nested tables would be an appropriate choice. Unlike associative arrays, nested tables can be defined as columns of a table in the database, where each entry in the column can hold a set of values. Nested tables represent sets of values. You can think of them as one-dimensional arrays with no declared number of elements. You see the syntax for creating nested tables and usage of the nested tables. In the example, a nested table type, department_mail, is created. The nested table will hold data of type varchar2. A variable mails of type department_mail is declared in the declare section. The nested table is initialized with values in the declare section. In the executable section, you retrieve these values with a for loop. Consider a situation where a company has an upper limit on the number of employees working in each department. In this case, we can use arrays instead of nested tables to hold the email IDs. A variable size array, var array, is an array with a fixed number of elements. The number of elements that the array would accommodate must be defined during declaration. A varray is valid in a schema-level table. Items of the varray type are called arrays. Varrays have a fixed upper bound on the number of elements, and you have to specify the upper bound when you declare them. This is similar to arrays in C language. The maximum size of a varray is 2 GB, as in nested tables. To access an element of a varray, you use standard subscripting syntax. You see the syntax for creating a varray and usage of the varray. In the example in the slide, a varray type, emp_male, is created. It will hold data of type varchar2 with a maximum size of 5 defined. A variable males of type emp_male is declared in the declare section. The varray is initialized with values in the declare section. In the executable section, you retrieve these values with a for loop. Associative arrays. These are key-value pairs where each key is a unique index associated with a value. The values in an associative array are indexed according to the key value provided during initialization. They cannot be persisted to a database, and can be used only in place SQL blocks. Nested tables. These store an unspecified number of elements in no particular order. They can be a table column and persisted to the database. Arrays. These store a specified number of elements. Arrays are indexed from 1 to the upper limit specified during declaration in the place SQL block. They can be a table column and persisted to the database.